Welcome at ICT University. In this video we'll cover one of the later technologies in use for displays, Organic Light-Emitting Diodes, OLED. Which is a very thin display that does not require any kind of backlighting. More specifically stated, each pixel of the image provides its own lighting and can therefore control its own luminosity, which can result in higher picture quality overall. OLED technology uses organic compounds to produce light through what's known as electroluminescence. Simply stated, passing electricity through those components so that they produce light. This is accomplished by placing the organic components within what's known as a thin film transistor, TFT. Which itself is then placed between an anode, or a device that produces a positive electric charge, and a cathode which produces a negative electric charge. The electric charge would flow from the anode through the OLED material to the cathode. And as the electricity passes through the organic compounds with varying parameters such as voltage and amplitude, the various levels of light and color would be produced. There are two different types of OLED, passive matrix OLED, PMOLED, and active matrix OLED, AMOLED. Like most things in technology, each approach has its pros and cons. Beginning with the passive matrix, this uses an approach that controls the image processing sequentially, one line or one row at a time, without using the thin film transistor, TFT, which itself contains a storage capacitor. By not using the TFT, most of the pixels in any given line are actually off most of the time, resulting in an image that is not as bright. To compensate, higher voltages are used, making them less efficient than the active matrix. And due to the higher voltage, over time, the organic compounds themselves tended to degrade, which decrease the lifespan of the display. None of that makes the passive matrix seem like a good choice. But they were cheaper to manufacture. Active matrix does use the TFT and its associated storage capacitor, which can maintain the state of any given pixel line, producing a brighter and more consistent image. But they were more expensive. The cost of active matrix devices has come down since its inception, and most OLED devices these days are likely using the active matrix, with the passive matrix only being used on specialized screens with lower resolution requirements, such as MP3 players, GPS devices, or other dedicated task devices. If we then compare OLED to an LCD screen that uses standard LED, the primary difference is that OLED can control the lighting on a pixel-by-pixel basis, whereas an LED-lit LCD screen relies on backlighting or on some smaller devices' edge lighting. OLED can offer a degree of dexterity and control that simply isn't possible with LED LCD. But there are still pros and cons of each. Most notably, the color capabilities. Most LCD screens these days can produce exceptional color quality, but it does still depend on the underlying technology being used, such as in plane switching and vertical alignment, both of which offer better color than something like twisted pneumatic, which tended to look washed out, especially as the viewing angle increased. OLED displays don't really have any issues with viewing angles because each pixel produces its own light. But early OLED devices especially, had difficulty with color accuracy and keeping them realistic to the eye. And while that specific aspect has improved over time, even the latest models can have problems with color volume, which refers to difficulty in maintaining even an accurate color saturation as brightness increases, meaning that for very bright scenes, the brightness simply overwhelms the color saturation so colors don't look as sharp. As for the viewing angle, as just mentioned, OLED displays by comparison to LED will generally offer a higher quality image even from significant viewing angles, because each pixel produces its own light. And because OLED displays are very thin and the pixels are very close to the surface. So, for something like a TV in your living room, it means that many viewers spread out in different spots won't lose out on image quality. LCD screens can vary, but again, it does depend on the underlying technology. For example, as just mentioned, in plane switching or IPS significantly improve upon this issue over technologies such as vertical alignment. IPS has become the most prominent technology for LCD screens, so the viewing angle itself is much less of an issue these days than it used to be. Plus, you also have to consider the application. Several people watching TV spread out within a room is really one of the most prevalent examples of when the viewing angle would really be an issue. For general computer use, users are going to be directly facing their display virtually 100% of the time, which of course, negates the issue on its own. It might be slightly more of an issue with handheld devices such as phones or tablets, since you might not always hold them at the perfect viewing angle. But again, the improvements made by the IPS technology will in most cases overcome those angles as well. Something else to consider when comparing display types is certainly the overall brightness, and this tends to be where LED and LCD win out over OLED, particularly for outdoor use for devices such as phones and tablets, where you might be competing with direct sunlight. And it's also something to consider when viewing high dynamic range or HDR video. The standard units of measure when it comes to brightness are usually either in nits or lumens. The nit refers to the brightness of a candle per square meter, whereas a lumen is just more of a defined standard that doesn't really relate to any day-to-day object like a candle. But in both cases, the higher the value, the brighter the display. Finally, contrast refers to the ratio of dark to light, and this is where OLED tends to win out. Since each pixel of an OLED display emits and controls its own light, up to and including emitting no light. In other words, the pixel can be entirely turned off. With an LED-LCD display there is always a back or an edge light, so particularly when it comes to reproducing a black pigment, a pixel that emits no light produces a true representation of black, as opposed to a pixel that is just doing its best to block out the backlight. Contrast ratios for top-end LED-LCD screens these days might be about 1000 to 1, meaning that the brightest pixel is 1000 times brighter than the darkest. But with OLED, since a pixel can emit no light at all, the ratio is only limited by how bright the pixel can get, so it can almost be thought of as an infinite ratio. There is certainly a limit as to how bright the pixel can get, but in short, LED-LCD can never get as dark as OLED can. Ultimately, the display qualities that anyone should look for are going to depend on many factors, but most notably, it should come down to the type of device and how it's being used. For example, you should not look for the same qualities in a gaming monitor as you would for a phone. They just aren't used in the same manner. Just be mindful of the application when determining the best type of display for your needs. That was it for this video. Thank you for watching.